Manmat, you mute yourself.
Good evening,
Man,
sir.
ah, good evening, good evening. You mute yourself.
Sir, sir, good evening, sir.
Good evening, good
Yes,
evening.
sir.
You mute yourself. Manmat,
Okay, sir.
mute.
Sir,
Yes, you mute yourself. Manmat, you mute yourself.
sir. Sir,
Arey, what, sir? You mute yourself. Anything you want to speak? So there are some background noise from your channel is coming.
sir, I'm,
Anything you want to speak?
sir, I am at my office, sir.
So you mute yourself. You
Okay,
keep
sir.
yourself mute. Huh?
Sir,
Yes,
no
yes.
need.
Do it, do it. And where are the other students? Only three have joined. So let us wait. Manmat, you mute yourself.
Sir,
Where are other students?
asking them. Just asking them.
Camera is not required. And you mute yourself.
Sir,
Where are other students? Will you wait 1 or 2 minutes? Otherwise, I will start.
They they will be coming soon.
What? Satyabrata, what you are telling?
We should wait 4 5 minutes
4 5 minutes. Why?
because nobody has arrived. That's why.
So is there any guarantee after 4 5 minutes students will come?
I think so, sir. Because yesterday there were many students.
Uh, and yesterday already we have talked that everybody will join before 6 p.m. today.
Yes, sir.
They have promised that they will join, but till now they have not joined. We will start the class at 6:05.
Okay, sir.
Manmath, you mute yourself.
okay, sir. You mute.
Satyavrata, you call you make a phone call to Manmath. Okay, okay, it is mute. Your camera video is not required. Srinivas, your video is not required.
Okay, sir. Okay.
Manmath, your video is not required. Video will take more data usage. Okay, now we'll start. We'll not wait further. We'll start. Yesterday we have discussed searching. How many types of what is searching? Who can say? What is searching? Anybody can say what is searching?
Finding the required item in a list or linked list.
Okay. And how many types of searching are there?
2.
What are they?
Linear search and binary search.
Linear search and binary search. We have discussed linear search. And what is the time complexity of a linear search? What is the time complexity of a linear search? What is? The linear search time complexity is the order of what? Big O
Or
or order of
order of the array or list.
order of n. Okay, if n items are there, n number
Yes.
of items are there in the list, then the time complexity in worst case, the time complexity of linear search is what? Order of n, big O of n. Okay, that we have discussed.
Yes,
Okay.
sir.
Now we'll go to discuss the next type of searching, that is our binary search. Today we'll discuss the binary search. Okay. Linear search is applied on a list which may not be sorted. It may be random, it may be unsorted, but binary search can be applied to the list. The list must be sorted. Otherwise, the binary search technique cannot be applied. When we apply the binary search technique, before applying the binary search technique, the list of items must be sorted in ascending order or descending order. Okay, binary search can only be applied on the sorted list. Okay, and your linear search uses how it is searches in sequential manner, one after another, like so it searches in the linear search of the list. But binary search searches the item using a new technique. That new technique is what? Divide and conquer method. Now, what is divide and conquer method? What is divide and conquer method? The divide and conquer method is nothing but it has 3 steps. First, it will divide the problem into number of sub-problems. Then conquer. Conquer means it will find out the solution of sub-problems. Then combine. Then it will combine the solutions of sub-problems into the solution of the main problem. This is divide and conquer method. Now, I am sharing my screen. You confirm me whether my screen is shared or not. My screen is shared. My screen is shared or
Yes.
not?
Yes,
Is
sir.
shared. Is shared. Okay. Okay. Now see here binary search. Okay. Now see here binary search. So binary search works on what? The sorted list. Means the list must be sorted. The list must be sorted. So that's why the binary search can be applied on the sorted list. This is the main criteria of the binary search, or this is the prerequisite of the binary search. This is the prerequisite or main criteria of the binary search. Okay. Or you can say this is the prerequisite of the binary search. Then the binary search is faster and more efficient than the linear search. The binary search is what? More efficient or faster than the binary linear search. Binary search is faster. And the binary search uses what? Divide and conquer method. It uses what? Divide and conquer method. Divide and conquer method means what? The list can be divided into number of sublists. Then the sublist can be divided into number of sublists. This way, it goes on division until a straightforward manner comes. Okay, until a straightforward manner comes. When the straightforward manner comes, then it will find out solution of the sub problems or small problems. It will find out the solution of the sub problems or small problems. That is known as conquer. And the third step is what? Combine. Then it will combine the solutions of sub problems into the solution of the main problem. This is the divide and conquer method. That we will see that how it is applying the binary search. So that we will see. Now here the binary search algorithm. Here you see this is the binary search algorithm. Okay, binary search algorithm. Okay. The binary search algorithm can be applied on the order list, means it should be sorted. Now suppose there is a list, okay, and this is sorted, and the list name is what? List of n. N is the size of the list. Okay, n is the size of the list, and the list name is list, and there is a item, that is item you want to search. Then how to search? This is our algorithm. The step one, what we do? Set low equal to 0, set high equal to n minus 1. In the step 2, set found equal to 0. The step 3, repeat step 4 and 5. Okay, this is step 4 and step 5 will be repeated until there is a condition. Condition is what? Low less than equal to high and found equal to 0. And then we will compute the mid, which will be low plus high by 2. So this is integer division. Then we will compare the item with the list of mid. If the item equal list of mid condition is true, then it will set the found equal to 1 and location equal to mid plus 1. Otherwise, it will go to check another condition. If the item is not equal to list of mid, then item might be less than or greater than. If the item is less than list of mid, then it will do what? High will be equal to mid minus 1. Otherwise, if the item is greater than list of mid, low will be equal to mid plus 1. This is end if. Okay, after that, this is end if. Now, if found equal to 1, then item is displayed, or item is found, it will display. Else, item is not found, it will display. Okay, this is. Now, all of you write this algorithm in your note first. Write this algorithm from step 1. From step 1, you write this algorithm first to your note, in your note, so that we will be understanding better. Now, all of you write in your note. And after writing your complete, you inform me so that I will continue. You write, and after you written complete, you say me so that I will continue. You inform me. Written complete.
Sir, after step 7, is there anything below?
No. Step 7 is last.
Okay, sir.
So yours complete. Okay. Now we'll discuss. Okay. So what will happen first? So there is a low and a high. Okay. Low equal to 0, high equal to n minus 1. That means what? If there is a list and list contains n items, suppose the list contains 5 items. Okay. So this list is what? Using the array. So means the list is starting from the index of 0, and the list will be end with the index n minus 1. That's why low is pointing to the first index of 0 of the list, and high is pointing to the last index of the list, that is n minus 1. So the low and high, these are two variables. So those are pointing to the first item of the low is pointing to the first item of the list, and high is pointing to the last item of the list. Then set found equal to 0. Initially, we have not found anything because initially we have not searched. That's why found becomes what? 0. Now we want to find. How to find? So we go on using a loop. Now how to do the loop? Here repeat step 4 and step 5. The step 4 and step 5, this will be repeated again and again until the condition is what? Low. If the low less than equal to high and found equal to 0, then the step 4 and step 5 will be executed repeatedly. Now here low less than equal to high, condition is true or false? Condition is true, because low is what? 0, high is what? N minus 1, means 5 minus 1 means 4. So 5 minus 1 is 4, so this is 0. So means 0 less than equal to 5 minus 1 4. So 0 less than 4 condition is what? True. And found equal to 0, this is also true. True and true equal to true. Since condition is true, then step 4 will be executed. In the step 4 is what? Compute mid equal to low plus high by 2. So low and high both will be added. Suppose low is 0 and high is, suppose, let's say 4. So 0 plus 4 equal to 4. 4 by 2 means 2. So mid will be 2. Now item, what you want to find, that item will be equal to list of mid. Mid means what? Mr. Just wait, somebody has joined. Okay, I have allowed him. Now list of mid means mid is what? 2. So in the 2 position of the list, if item both are same, then we will do what? Found equal to true means 1, and location equal to mid plus 1. Otherwise, if item is not equal to list of mid, the item might be less than list of mid, or item might be greater than list of mid. Then it will come to the else if. In the else if, item less than list of mid, if condition is true, then high will be equal to mid minus 1. Otherwise, else if item is greater than list of mid, this is list of mid, not mod, this is mid, then low will be equal to mid plus 1. Okay. So this way, this will continue again and again until this condition is true. Okay. And when this condition will be false, this will stop and will come to step 6. So by that repetition, either the found will be 0 or found will be 1. If the found will be 1, then it will display the item is found. Otherwise, it will display the item is not found. Okay. So this is happening. This is the algorithm. And the C function, the same thing I have written here, same thing. Only there is a function header. This is the function header. This is the curly bracket, and this is the declaration of the variables. Otherwise, this low equal to 0, high equal to n minus 1. This is your step 1. Found equal to 0, this is step 2. While low less than high and found equal to 0, this is step 3. Mid equal to low plus high by 2, this is step 4. If item equal to list of mid, this is step 5. Okay. And if item equal to 1, this is your step 6, like this. And step 7 is what? End. Same thing is written here in C language structure only. In C language, it is written. In your exam, it will ask you write an algorithm, means you have to write the algorithm. Write an algorithm for the binary search, means you have to write this one. Or it will ask you write a C function for the binary search. You have to write a C function. And sometimes it asks you write both algorithm and C function, means you have to write algorithm as well as C function. Okay. If you remind anyone, you can write the other. Okay. If you remind the algorithm, you can write the C function, or if you remind the C function, you also can write the algorithm. So no issue, because both are same almost, only the writing structure is changed. Okay. Now the program is what? Now suppose we will take the one list, suppose enter size. Okay, we will give the size of the list, and it will ask us the size of the list. After that, we will enter items, and after entering items, then we will enter some one item. So that one item we want to search. So for that, there is a binary search. Whatever the binary search function we have written here, that function is written there in the program. And this is the whole program. This is the whole program of the binary search. Now, when this is called, now it will what? Display. It will display. Now we'll go to example. We will see that in the example how it is happening, and when I am executing this program, this is known as the dry run. When I am telling, you just see the your note where you have written the algorithm, you see that. Now here enter size, it is asking me enter size. Okay, then enter items. Suppose you give 5 size, then 5 items will be entered. Then it will ask to enter item which will be searched. So that is happening here. Now enter size, 5 is given. Now it will enter 5 items. Suppose 5 items, so we have entered 10, 22, 45, 51, 90. Okay, after that we want to search, suppose 45. Enter item to search 45. Now 45 is present there. So it will tell us that item 45 is found at 3, means location 3. Now how it is running, how it is happening, or how it is running. So that now we will see. Now, so initially we have given here 5 means n becomes 5, because here we have written what ampersand n. Here enter size, when we give 5, so that 5 will be stored at n. Okay, the variable n will be 5. That's why here I have taken the n equal to 5. And when we enter 5 items, here there is a loop. We have taken for I equal to 0, I less than n, I plus plus. Then we have written scan a percentage d ampersand list of I. Means 5 items will be scanned and stored in the list of 0 to list of n minus 1. Means list of 0 to list of 4. So here items will be stored from list of 0 to list of n minus 1. That is 4. So, okay, and whatever the item we have given first item 10, so 10 will be stored in the list of 0, and we have given 22, that will be stored in the next location, that is list of 1. And when we have given the 45 is the third item, that will be stored in the next position, that is 45 in the second location or second index. Okay, so this way items will be stored, that is 10, 22, 45, 51, and 90. Okay, and now we want to search it. And when we want to search it will ask us to give an item to search. Suppose we have given item 45 to search. Now the search will be executed. When the search will be executed in the search function, in the binary search function, first low will be equal to 0 and high will be equal to n minus 1. Now here low becomes 0. Okay, because low is pointing to the first index of the array. Okay, and high is pointing to the last index minus 1, means 5 minus 1, that is this one, because we have written high equal to n minus 1. Okay, so after that there is a loop. Okay, after that there is a loop. Now while low less than equal to high, so low is what 0, high is what 4. So 0 less than equal to 4, condition true, and found equal to 0, condition true. Now condition true means mid will be found out. Now condition is true, now mid will be found out. Here mid is found out. How the mid will be found out? Low plus high by 2. Low is what 0, high is what 4. So 0 plus 4 equal to 4. 4 by 2 equal to 2. Now mid value will be 2. Means mid is now pointing to the middle location of the array. Okay, middle location of the array. Then we will check the condition if. Now we will check the condition if. Okay, here if is there. Where is if? Here. If item equal to list of mid, item is what 45, and list of mid is what 10. Item is 45 and list of mid, here you see. List of mid is also 45. Okay, our searching item is 45 and our list of mid is also 45. Now if condition is true. Now since if condition is true, now found will be equal to 1 and location will be mid plus 1. Now found will be equal to 1. Okay, and location will be equal to, just wait. Okay, now found will be equal to 1 and here location will be equal to mid plus 1, means 3. Then it will display, it will come to, now after that here while loop will be false, because found is 1 now. While loop is false, then it will come to the if condition. If found equal to 1, is found equal to 1, then it will display item found. Okay, then that's why it is displaying item found. Okay, so this much is clear. Now this much is clear to you, or any doubt?
No, sir.
Clear.
Clear.
Clear? All of you clear?
Yes, sir.
All of you clear? Now what you do, all of you send the message. So there is a chat. In the chat you send the message, your enrollment number and name, that you send in the chat. So there is a chat That I will show you, chat with everyone. All of you send the message. Today you send the message. Are you sending the message? All of you send the message. Your registration number, then full name. Manoj Kumar, you do not present. Why you are doing the mistake? Last class also you have presented. Okay. So all of you send the message, your enrollment number and name. Have you sent?
Yes, sir.
All of you send?
Yes,
Yes.
sir.
Today, all of you sent?
Yes, sir.
Shiv Saurabh, you have sent? Today, you have sent? Ojus Binit, you have sent?
Yes, sir.
Satyabrat Samal, today you have sent?
Yes, sir.
Message, your
Yes, sir.
enrollment number and name.
Yes,
Srinivas,
sir.
Srinivas, you have sent?
Yes, sir. I already sent.
Okay. Manmat Baral, you have sent? Manoj Kumar, you have sent?
Yes, sir. Yes, sir.
Venkat Raman,
Yes, sir. I have already sent, sir.
okay. Umang, you have sent. Okay.
Yes, sir.
Now all of you mute yourself. All of you mute yourself. All of you mute yourself. Okay. My screen is shared. My screen is visible to you. Yes or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay. Now listen. So here we have given 5 items like 10, 22, 45, 51 and 98, and we are searching 45. Now 45 is searched here. Now tell me how many times the while loop is executed to search 45? How many times? How many times the body of the loop is executed to find out 45? How many times? Once or many times?
So one time.
Once. Okay, only once. Okay, only once the mid is found out. Means to find out 45, the loop is iterated only once. Okay. Now suppose we want to find another item. That is, suppose we want to find, let's say, we want to find 22. Now, when we want to find 22, how it is happening? Now, since our item is 22, so here low will be equal to 0, high will be 4, and mid will be what? In the first iteration, mid will be 2. Okay, after that 2, then the if condition will be compared. In the if, what is written? In the if, it is written that item equal to list of mid. So item is what? 22, and list of mid is what? 45. So item equal to list of mid means for 22 equal to 45, condition is false. You see here that we have written after this mid found out. Then we have written what? If item equal to list of mid, this condition is false. Since this condition is false, then it will go to the else if. That is, if item less than list of mid, yes, it is true, because item is what? 22, list of mid is what? 45. Now since condition is true, now high will be mid minus 1. So high will be what? Mid minus 1. What is mid? Mid is 2. 2 minus 1 is what? 1. Now high will be equal to 1. That is happening there. You see there, high is happening what? 1. Because high equal to mid minus 1 means 2 minus 1 means 1. Okay, high is that. After high found out, then in the second iteration, we will again find out mid equal to low plus high by 2. Okay, in the second iteration, we will find out mid equal to low plus high by 2. Low is what? 0. High is what? 1. 0 plus 1 equal to 1. 1 by 2 is what? 0.5. So 0.5, its integer value is what? 0. That's why mid will be now 0. Now mid will be what? 0. So low equal to 0, mid equal to 0, and high equal to 1. Now we'll check the value. So item is what? 22. Now item equal to 22, item equal to list of mid, condition false. Then item less than list of mid, because item is what? 22. List of mid is what? 10. Now item less than list of mid, condition false. Then like this, here you see. So it will check first item equal to list of mid, condition is what? False. Then it will come to else if item less than list of mid, this condition is what? False. Then it will come to here item greater than list of mid, item is what? 22. List of mid is what? List of mid means list of 0. List of 0 means 10. So 22 greater than 10. Condition is what? Condition is true. Condition true means now low will be mid plus 1. Now low will be what? Mid plus 1. That's why now the low will be what? Mid plus 1. Now here low will be what? Mid plus 1. Mid plus 1 means what? 0 plus 1. 0 plus 1 means 1. Now your low will be what? Mid plus 1 means 0 plus 1. In the next iteration, now this is the third iteration. In the third iteration, now it will find out mid equal to low plus high by 2. Low is what? 1. High is what? 1. 1 plus 1 equal to 2. 2 by 2 equal to 1. 2 by 2 equal to 1. Now this will be what? Low plus high by 2. So this will be now mid. Mid is what? 1. Then it will check condition if list of mid equal to item, or if item equal to list of mid. Item is what? 22. And list of mid is what? 22. Now condition is what? True. Because here you see item to find is what? 22, and list of mid is what? 22. Since both are correct, now it will find out the item and item found will be displayed. Now how to find 22, how many iterations done? How many times the loop executed?
Sir, 3 times.
3 times. Okay.
Yes, sir.
3 times. 3 times the loop will be executed. Okay. Similarly, we will see to find out 10, suppose. Now to find out 10, here, if we want to find out 10, item 10, then it will iterate 2 times. It will iterate what? 2 times. Similarly, if we want to find out 98, then it will iterate what? 3 times. 98 is 3 times. If we want to find out 51, the 51 will iterate how much? 51. Then it will take what? 2 times. If we want to find item which is not present, suppose 64. Now 64 is not present there. Now how many times it will iterate? How many times it will iterate? How many times? So it will iterate how many times? 3 times only. It will iterate 3 times only to find the item which is not present. First iteration, second iteration, third iteration. After third iteration, low less than high will be false and will be stopped. And if we found equal to 0, 1, if we found equal to 1 will be false. So it will not show the item. It will see the item not found. It will show you item not found. Okay. So this is what? This is your binary search. Again, I am telling to find 45, 1 iteration. To find 10, 2 iteration. To find 22, 3 iterations. To find 51, 2 iterations. To find 98, 3 iterations. Yes or not? 3 iterations required. Yes or not? So here, if there are 5 items, the maximum number of iterations required to find any item or to find the item which is not present, it requires only 3 iterations. It only requires what? 3 iterations. If you have 6 items, also 3 iterations. If you have 7 items, also 3 iterations. Means if you have 7 items to find out any item which is present or which is not present, it will require what? 3 iterations maximum. 3 iterations maximum by using the binary search. Now tell me, suppose you have 5 items and you want to find the item which is not present. How many iterations it will do using
Sir,
the linear search?
Lead.
Linear search.
So 5 iterations.
It
5
will take.
5 iterations. Yes or not?
Yes, sir.
But binary search requires what? Only 3. So which one is faster?
Binary.
Binary
Binary
search.
search.
Binary search. Similarly, suppose you have 15 items. If you have 15 items, the binary search requires only 4 iterations. Only 4 iterations. If you have 15 items, then if binary search requires a maximum. You mute yourself. Who is doing that? Mute yourself. Okay, so if 15 number of items are there, the binary search can search any item which is present or not present by implementing only four iterations. If it has 31 items, then 5 iterations required. If it has 63 items, then it requires maximum six iterations. So this way means how I know this, because if n number of items are there, then binary search requires log n times. So log of 7 is what? Log of 7 is 3. Log of 15 is what? Log of 15 is 4, and log of 31 is what? 5, and log of 63 is what? 6, like this. Okay, means here if n number of items are there, the binary search requires log n times. Log n is very smaller than n. Now suppose there are 1000 items. To search a item which is present or not present, the binary search, the linear search takes 1000 iterations. Order of n means what? Order of 1000 means 1000 iterations required in the linear search. But binary search requires only 10 iterations.
10
Only
iterations.
because log of 1000 equal to 10. Log of 1000 means 2 to the power 10 equal to 1024. 2 to the 10 equal to what? 1024. This is. You got it? Suppose 1 lakh. 1 lakh is there. Now 1 lakh items are there. The linear search can take 1 lakh. But binary search can take 1 lakh log of 1 lakh. And log of what is log of 1 lakh, you can find out. Okay, this should be very small. Okay, all of you got it? So this is the fasterness of the binary search. Now the binary search is this much faster. Now the binary search is this much faster. All of you got it?
Yes,
Yes,
sir.
sir.
Yes,
Clear?
sir.
Now there is a difference between the linear search and binary search that you see here. That's why here the binary search, if you have 7 items, the binary search takes 3 iterations. Suppose 15 items, the binary search requires 4 iterations. 31 items, it will take 5. 63 items, it will take 6. 127 items, it will take 7. 255 items, it will take 8. 511 items are there, 9. Then 1023 items are there, then it will take 10. 2047 items are there, it will take 11. But linear search can take 2047 iterations. Okay, the in linear search it requires 2047 iterations, whereas the binary search only requires 11. Only 11 but 11 iterations. Okay, so that's why the time complexity of binary search is what? Order of log n. Now if you see the comparison between the linear search and binary search, this is the comparison. The linear search, the list can be unsorted, sorted, or any random order to apply the linear search. But that is not there in the binary search. In the binary search, the list must be sorted. The list must be sorted. The binary search list must be sorted. Now the linear search is what? This is sequential approach. Means it searches the item one after another. After one, then next, then next, then next, one by one, one by one. Okay, but binary search searches by using the divide and conquer approach. The time complexity of linear search is what? Order of n. The time complexity of a linear search is what? Order of n. The time complexity of a binary search is what? Order of log n. Just we have discussed what is log n. Order of log n. Now the linear search is what? Slower. Binary search is what? Faster. Binary search is what? Faster. The linear search is not efficient, but binary search is efficient than the linear search. The linear search can be applied on arrays as well as linked list, but binary search can only be applied on cannot be applied on linked list, only can be applied on array. The linear search is better for a small size array, but binary search is better for a large size array. All of you got the difference between the linear search and binary search?
Yes, sir.
Yes, sir.
To mute yourself, somebody has unmute. Why he is making unmute? Okay, so this is the difference between the linear search and binary search. All of you clear? All of you clear? Now
Yes,
write.
sir.
Okay, this difference you write in your note now. Very quick you write difference. Linear search, binary search, this difference you write in your note.
Shut down.
Done. Okay. Okay. Now we'll discuss a new thing. That is, this is the new thing to you, and you see, this is what are the data structures? Yesterday we have discussed. What are the data structures?
Array, linked list, stack, queue, graph,
Hmm.
and
And others tell what are the data structures?
trees.
Okay, the data structures are array, stack, queue, linked list, tree, and graph. We assume that the array data structure you know because you have already studied in the previous semester in programming C. The teacher has taught you what is array. So array data structure has been known to you. Okay. Now today we will discuss from the stack. Okay. So we'll discuss other data structures, which is the first data structure is what stack. Now what is the stack? You mute yourself. You mute. Now what is the stack? Simply I can give you some example. Now suppose there is a chair. Upon one plastic chair, molded plastic chair, upon one chair you can keep another chair. Then upon that chair you can keep the third chair. Upon that chair you can keep another chair. And we say number of chairs are stacked there. Means this is what? This is stack of chairs. Or suppose another example, suppose there is a book. Upon one book, we can keep the second book. Upon second book, you can keep the third book. Upon third book, you can keep the fourth book. This way, you can make a stack of books. Or suppose there is these plates are there. Okay, plates are there, or these plates are there where in which we eat. Okay, these plates are there, or dishes are there, or these plates are there. Okay, upon one plate you can keep another plate, then above the that plate you can keep another plate, above that plate again you can keep another plate. So this is a stack of plates. So either stack of plates, stack of dishes, stack of your chairs, or stack of books. So these are what? These are stack. Okay, now tell me, this stack has how many ends? How many ends? This stack has how many ends? Anybody?
One.
One end. Which one that end? Into which we insert items and from which we delete items. Yes or not? Into which we insert items and to which we delete items. So this is what? This is your what? This is your end. Okay. And this end is known as what? Top end. Because the bottom end is fixed with the ground. The bottom end is what? Fixed with the ground, and the top end is open, into which you can insert new items and from which you can delete old or existing items. That's why there is one end, and that end is known as what? Top end. That one end is known as what? Top end. So this stack is nothing but this is an order collection of items. The stack is nothing but this is an order collection of items into which new items are inserted and existing items are deleted from one end. And that end is known as what? Top. And when we go on inserting items to the stack, the top is increasing. When we deleting items from the stack, the top is decreasing. And this stack is what? This is a linear data structure. The stack is what? This is a linear data structure. And stack is in nature, this is LIFO, means last in, first out. The item which has come last will be deleted first. This is LIFO, or this is LIFO means last in, first out. Okay. So this is your, and the, you see this. So this is the order collection of items in which a new item is inserted and an existing item is deleted from one end. The end into which item is inserted and from which existing item deleted is called top end. And the stack has only one end because the top that is your top end, because the other end is close to the ground. the stack is what? This is a linear data structure. The stack is LIFO in nature, means the last inserted item will be deleted first. For example, stack of books, stack of dishes, stack of chairs. This is your what? Stack. Okay. Now, what are the stack operations? Now, what are the stack operations? So, there are operations of the stack. When you insert items, this is known as insertion or push operation. This is what? This is push operation. When you delete items from the stack, this is the deletion operation, or this is the pop operation. This is what? This is the pop operation. But before push operation, there is a creation operation. The stack must be created first, means creation. And once the stack is created, then you can traverse the stack. So totally there are four operations. One is what? Creation. One is the creation. Second is the push. Third is pop. And the last one is what? Traversal. So these are the operations of the stack. These are the operations of the stack. Okay. Then the implementation. The stack can be implemented by using two data structures, either array or linked list. If you implement the stack using array, we say this is what? This is a static stack. If you implement the stack using linked list, then we say this is a dynamic stack. Okay. The stack can be static stack if you use the array. The stack can be dynamic stack if you use the linked list. Okay, this is what? Static stack and dynamic stack. Okay, so now stack using array. So stack using array data structure is what? This is a static stack. Okay, and to implement a static stack using array, we have to do the following operations. That is creation. Okay, that is what we have to first do the creation. Second, what we have to do? Push. Third, what we have to do? Pop. And fourth, what we have to do? The traversal. Okay, now come to the first operation, that is your creation operation. In the creation operation, how to create a stack? The stack can be created by using array, just by declare the array, and array name should be the stack name, and array size should be the stack size. The stack size should be array size, the stack name should be array name, and you have to declare this by using array. By using array.
Array.
Yes, array. Okay, and here this is done. How you see? So how you see? Has defined max size 5, means your a macro is taken, and that macro is what? Max size. The name of the macro is max size, and its value is what? 5. The name stack max size. So stack is what? This is an array, but name of the array is what? Stack. And what is the size of the stack? The size of the stack is the size of the array. And the initially you have to take the top equal to -1, means this happens. So an array is declared here like this. An array is here, an array is declared. Okay, and the size of this array is what? 5. So starting from 0 index to index 4, and top equal to what? -1. Initially top equal to what? -1. Okay, so this is what? This is the creation operation. This is created. Then the second operation is what? The next operation is the push operation. In the push operation, what do we do? We insert items to the stack using array. And when you insert items to the stack using array, which is the push operation, the top value is increasing. The top value is increasing. Okay, and the top value can increase up to maximum the max size -1. And after push operation, the stack will be full. Suppose the stack size is 5 and 5 items are pushed, means now the stack is full. Once the stack is full, further insertion of items to the stack full will be overflow. Will be what? Overflow. Okay, now this is the algorithm for the push operation. This is the algorithm for the push operation. All of you now write the algorithm of the push operation. Write in your note the algorithm of the push operation.
Sir, done.
Done. Okay. Okay. Now you draw this picture. Draw this picture.
Done.
Done. Okay. You see here what is happening. You see here what is happening. Okay. So this is the algorithm. Okay. Now in this algorithm, what is happening here? The step one is what? Step one is what? If top equal max size minus one. So initially top equal to minus one. So initially this condition is what? False. Okay. Initially this condition is what? False. This condition is written to check whether the stack is overflow or not. If the top value becomes 4 and max size minus 1 will be 4, so top value equal to 4, max size minus 1 equal to 4, so condition is true, then it will display the stack overflows and it will not allow you to insert items into the stack. Means it will go to the step 4 which will be stop. Otherwise, you can insert items. Now, just newly created our stack where the top equal to minus 1. Now we can insert. Means we can do the push operation. So that's why we will call the push operation. We will call the push operation push 10. When you call push 10, now this algorithm will be executed. Now step 1 is what? False. Because top is what? Minus 1. Max size is minus 1 is equal to 4. So minus 1 equal to 4 is what? Condition false. Means step 1 is false. Now compute, it will go to step 2, which will do the compute top equal to top plus 1. What was the top? Top was minus 1. Minus 1 plus 1 equal to 0. Now top will be 0. Now top will be 0 like this. Okay, this is your stack. You see this. This is your stack. And here top equal to minus 1 plus 1 equal to 0. Then top is pointing to the 0 index. Then item 10 is inserted, means pushed. Now suppose again I want to push 20. When I want to again push 20, now the top will be what? This step 1 is false. Now step 2 will be executed, means top will be 0 plus 1 equal to 1. Means top is pointing to the 1 index and 20 will be stored. Here set stack of top equal to 20. So say stack of top means stack of 1 will be equal to item. Item is what? 20. Now suppose I want to push 30. Now I want to push what? 30. When I want to push 30, now what is happening here? What is happening? So it happens that first the step 1 condition will be checked. Now step 1 condition is what? Step 1 condition is false. Since step 1 condition is false, now come to the step 2. Compute top equal to top plus 1. Top is what? Top is what? Here 1 plus 1 equal to 2. Now top is
2
pointing
plus
to
1.
okay. Okay, when you push 30 now, when you first push 40, this will be top plus 1. Means 2 plus 1 equal to 2 plus 1 equal to 3. Okay. Now suppose again you want to push. Now suppose again you want to push. Now what is the value of a top? Top is 3. So if top equal to max size minus 1, 3 equal to max size minus 1 means 5 minus 1 is equal to 4. So 3 equal to 4. Condition is what? Condition false. Now condition false means what? It will display stack over. It will not display stack overflow. Rather it will go to step 2. Which will be compute top equal to top plus 1. Now top will be top plus 1 means what? Top will be 2 plus 1, that is 3. Okay, that is 3. Now this will be 3 plus, okay, that is 3. And stack of top means stack of 3 will be equal to 40. Okay. Now suppose I want to push 50. Now suppose I want to push what? 50. Okay. Now the item is what? 50. Now step 1 is what? Step 1 is false because earlier the value of a top was what? 3. Now 3 equal to max size minus 1. Condition false. Condition false means what? This will not be executed. It will come to step 2. Now compute top equal to top plus 1. Top is what? 3 plus 1 equal to 4. Now top will be 4. And top is pointing to the 4th index. Now set Stack of top means stack of 4. Stack of 4 equal to item. So item is what? Item is 50. So stack of top equal to item means 50 will be stored in the stack of top. Okay. So now what is the size of stack? The size of the stack is 5. And how many items are pushed? Already 5 items are pushed. Now stack is what? Now stack is full. Now stack is full. Now whether our algorithm is correct or incorrect, that we'll see. Once the stack is full, it should not allow the more item to insert or to push. Whether that is happening or not, we'll see. Now, so again, suppose we want to further push item 60. Okay, when we want to push item 60, now it will first execute the step 1. So step 1 is equal to what? If top equal to max size minus 1. If top equal to what? Max size minus 1. Now top equal to what? 4. Max size is what? 5. 5 minus 1 equal to what? 4. So top equal to 4. Max size minus 1 is 4. Now 4 equal to 4. Condition is what? Condition is true. Condition true means it will display stack overflows. It will display what? Stack overflows. It will display stack overflows. And it will not allow you to insert 60 into this stack. It will not allow you insert 60 into this stack. Okay. So 60 cannot be pushed. Okay, and rather this will be overflow. So this is your push operation. This is your what? Push operation. All of you clear? Push operation.
Yes, sir.
Yes, sir.
All of you clear? Okay. Already you have done the WhatsApp group. You have done the WhatsApp group. Okay. So I will share after this push operation, there is the pop operation. This is the push function. Okay, push operation. This is your push function because the same algorithm is written in the C-like structure. The same algorithm is written in the C-like structure. This is the push operation in C function. The next is the pop operation. But pop operation, we have no time to discuss the pop operation. In the pop operation, there is an algorithm. Okay, there is an algorithm. We have no time to discuss. Okay, now we'll stop here. Okay, we'll stop here. Now. Okay, so this this slide and our this material. So both this material I will share to you, so you can find. So already you have made the WhatsApp group.
Yes, sir.
Okay.
Yes, sir.
Okay. Okay. So there I will share. Okay. So now
Okay,
we'll
sir.
stop. Now we'll stop because
Yes, sir.
your time is over. Now
Okay,
stop.
sir.
Okay. Just wait. Just wait. Don't leave. Just wait.